Hello everyone, welcome to the video lecture series on inverse Laplace transforms. My name is Mayur Gohil. In this video lecture we would be solving problems of inverse Laplace transforms using partial fractions, and we would be seeing little insight into it. So let us take up a problem. This is our question and we have to use partial fractions. First of all, observe this phi of s. Here this case goes to the case number 2 of our partial fractions, because if you observe, there is this factor is repeated 3 times and this factor is repeated only once. So we can express this in this manner, that is a over s plus 3, b over s plus 1, c over s plus 1 the whole square, and d over s plus 1 the whole cube. Now why it is happening? Because s plus 1 is a factor which is repeated 3 times, so you write all the powers 1, 2 and then 3, and here it is s plus 3 which is just repeated once, so you just write it once. Okay, now let us go to the next step. This is what you obtain on simplification. Now this is the main step which many students ask, that how to obtain it. So what you have to do is that you have to take the denominator of LHS and multiply it to the right hand side. Okay, so when you multiply it to right hand side to each of these terms, okay, then what happens is that on simplification, in the first term, if you observe, when you multiply it, this s plus 3 and s plus 3 gets cancelled, and what is left out in the numerator is s plus 1 the whole cube. Similarly, you do it over here, you obtain these terms, and then s plus 3 into s plus 1, and finally when you multiply the denominator to the last term over here, s plus 1 the whole cube gets cancelled, and what is remaining is s plus 3. Okay, now in order to simplify this equation further, that is, we have to find a, b, c and d. So in order to find these constants, what we can do is observe the roots of this denominator. What were the roots? The roots over here are -3 and -1, right? So I'll substitute first -1, because what I see is that when I substitute -1 in this equation, okay, this entire equation, what I see is that a gets, this term vanishes, this term vanishes, and this term vanishes, because -1 plus 1 is 0. So a term is gone 0, this is all coefficients go down to 0, but this d remains, so I obtain value for d. So d is equals to half. So you substitute -1. Now you substitute s equals to -3. Similarly, you obtain the value of a, that is 1 upon 8. Similarly, now there are no other roots left out with us, so you can now put random values. So randomly I will have the value 0, so I'll put s equals to 0. It simplifies my work. So when I put s equals to 0, I obtain one equation. Okay, so there are 4 terms over here. Okay, now next thing is that I'll now try to put any another random value, say s is equals to 1, then I obtain 3 is equals to 8a plus 16b plus 8c is equals to 4d, where you have to put this s equals to 1 in this equation, okay, on both the sides. Okay, so when you substitute this value, you get these equation, but you already know that you have value of a and value of d. You substitute those also over here, then you obtain 2 equations in b and in c. Okay, so you solve them simultaneously and obtain the value of b as -1 over 8 and c as 1 by 4. That's it. Having solved for a, b, c and d, you can substitute these values in this expression. Okay, so you substitute it over there. Be careful while substituting, because there is this minus sign involved, and then use appropriate brackets. Okay, after this, what you are supposed to do is operate the inverse operator L and L inverse operator, and then L inverse operator distributes over each of the term because it is a linear operator, as well as the constant will pop out. So having done that, you take the inverse Laplaces. What are the inverse Laplaces of each of the term? This inverse Laplace of 1 upon s plus 3 is e to the power minus 3t. For this it is e to the power minus t. Over here it is e to the power minus 3 times t. And for this it is e to the power minus t times t square divided by gamma 3, and gamma 3 is nothing but 2 factorial. And so if you simplify it, it would be nothing but 1 upon 4. So that's it. Okay, now the main goal of explaining this example was that you can understand how to solve for partial fractions and obtain your inverse Laplace. Okay, here one more thing is there, that I have chosen values like -1, -3, 0 and 1. You can choose any other values also, say 7, 9, 10, whatever you find it comfortable, and you will still get your answer, but the calculations will increase. So try to minimize your calculation. This was by trial and error we did it. So some calculations we had to do, and you can also do it easily. So try to take easier values so you can minimize the number of steps and get your answer as quick as possible. Okay, now let us move on to the next problem of finding inverse Laplace using partial fractions. Here we saw this trial and error method. There we will see some another method. Let us see that method. The question is, we have to find L inverse of this phi of s. So it's a big one. S plus 2 over s square plus 4s plus 8 times s square plus 4s plus 13. Now similarly we have to express this as as plus b over the first quadratic, then cs plus d over the second quadratic. Why? Because if you observe that b square minus 4ac for each of the quadratic is negative. Okay. How can we obtain the coefficients a, b, c and d? That is what our main question is. So the first thing is express s plus 2 equal to this. Okay, what you have to do? You have to cross multiply the denominator to the RHS. Okay, so when you do it, you get this as your final expression. Now in order to get a, b, c and d, if you now do random substitutions, you will get a system of equations and you can still perform. But there is one more method to this. I am now going to perform ordinary multiplication of polynomials onto the right hand side. When I perform ordinary multiplication of polynomials onto the right hand side, I obtain these two expressions. This is the first multiplication, and then this is the second multiplication over here. Okay, now having done the multiplication, and then you can take common terms, like you can collect the terms with like powers. S cube can be collected, that is a plus c is the coefficient. S square can be collected, then the coefficients are there, and then with s whatever terms are there that can be collected, and the constants can be collected again. Now you compare the, because you compare the LHS and RHS because both are polynomials in S. So two polynomials are equal if and only if their coefficients of corresponding terms match. So s cube coefficient on LHS is 0, so a plus c is 0. Okay, so similarly you compare the coefficients, you get these equations. These four equations you obtain. On solving these four equations, you obtain the value of a, b, c and d. Okay, then you substitute it into the main expression, and you obtain this as your answer. After this, okay, what we are expected to do is, now you operate inverse Laplace operator. When you operate inverse Laplace, it distributes over the minus sign and constants come out. Okay, do the completion of the square of each of the denominators. So I have completed the square because it is same as s square plus 4s plus 4 plus 4. So that can be expressed in this manner. Why I have completed the square? Because this s plus 2 I need to vanish it. So s plus 2 I am trying to express everything in terms of s plus 2. Having done that, I see that I can now use first shifting theorem. So when I use first shifting theorem, it is e to the power minus 2t comes out, and then it is L inverse of the remaining s over s square plus 2 square. This s plus 2 is replaced by s then. Okay, having done that, now I see that this is nothing but inverse Laplace of cosine 2t. So I replace that, and then here I see here it is the inverse Laplace of cosine 3t. So this is my final answer. Okay, so I have explained you two methods of finding inverse Laplaces using partial fractions, and in one method we saw by trial and error for going for the coefficient finding, other one we saw doing ordinary multiplication and comparing the coefficients to find comparing the powers and finding the coefficients. Okay, so that is also allowed, so you can do whichever suits you and you can tackle for the problem. So that's it for today. Thank you.